In the previous session, we have looked at homogeneous systems. Now let's solve a couple of problems. Let's say we have a system of equations. X plus 3y minus 2z equal to 0, 2x minus y plus 4z equal to 0, x minus 11y plus 14z equal to 0. Now, it's clear that this is a homogeneous system of equations because of the zeros as the constants. So our equation will be ax equal to O, where a is equal to 1, 3 minus 2, 2 minus 1, 4, 1 minus 11, 14. Now let's do row operations. And the objective is to bring it to the reduced row echelon form. So we have the reduced row echelon form. And here you will notice that there are two pivots. So rank of A is equal to 2 and number of variables is 3, that is n equal to 3, which implies n is less than 3. So if n is less than 3, we have seen in the previous session, non-trivial solutions exist. So using the equivalent system from this matrix, we get x plus 3y minus 2z equal to 0, minus 7y plus 8z is equal to 0. So y is equal to 8z by 7 and x is equal to minus 10z by 7. Rank of A is equal to 2, which implies one variable z remains unrestricted. How? Because remember, the free variables are given by n minus rank of A. So 3 minus 2, 1. So one variable z remains unrestricted. Now we are free to choose the value for z. Preferably we choose k such that we get integer solutions in their simplest proportion. So let z is equal to 7k. So that 7 in the denominator of minus 10 by 7 and 8 by 7 gets cancelled. Now if two fractions do not have the same denominator, we take the LCM. So x is equal to minus 10 times 7k by 7. Y is equal to 8 times 7k by 7 and z is equal to 7k. Simplifying, we get x equal to minus 10k, y is equal to 8k, z is equal to 7k. Thus, the general solution depends on one parameter and the solution space has one basis. Now, geometrically, the intersection line is the solution space. Because ultimately, by solving this system of equations, what are we arriving at? We are arriving at the intersection of three planes. So the intersection line is the solution space, which is given by this matrix, minus 10k, 8k, 7k, where k is in real numbers. Every point on the line is a solution of the system. When k is equal to 1, it forms a basis for the solution space. So that was our first problem. Now let's look at the second problem. Now find lambda in the set of real numbers such that there is a non-trivial solution. So we are given this system of equations, x plus 2y plus 3z equal to lambda x, 3x plus y plus 2z equal to lambda y, 2x plus 3y plus z equal to lambda z. Now it might look as if this is not a homogeneous system, but this is x, y, z, and here also we have x, y, z. So let's bring the lambda x, lambda y, lambda z to the left hand side. Then we get 1 minus lambda x plus 2y plus 3z equal to 0, 3x plus 1 minus lambda y plus 2z equal to 0. Then finally 2x plus 3y plus 1 minus lambda z equal to 0. So we have the homogeneous system of equations. Now the coefficient matrix will be A is equal to 1 minus lambda, 2, 3, 3, 1 minus lambda, 2, 2, 3, 1 minus lambda. It is a square matrix. So non-trivial solutions exist only if the determinant of A equal to 0. Just a little bit of explanation for this. For a homogeneous system, non-trivial solutions exist only if the rank of A is less than n. Since A is a 3 by 3 matrix, n is equal to 3. Therefore, rank of A is less than 3. For a square matrix, rank of A is less than n if and only if the determinant of A equal to 0. So since it is if and only if, we can look at it in either direction. Okay, so now that means we have to find the determinant of A. Let's simplify this or reduce it using row operations. R1 replaced with R1 plus R2 plus R3. R2 replaced with R2 minus 3R1. And we also factor out 6 minus lambda from R1. R3 replaced with R3 minus 2R1, which implies basically taking the expansion of this determinant 6 minus lambda times this expression equal to 0. Now we keep simplifying it to get 6 minus lambda times lambda square plus 3 lambda plus 3 equal to 0. Now, if the product is 0, then 6 minus lambda equal to 0 or lambda square plus 3 lambda plus 3 equal to 0. This is a linear equation in lambda. This is a quadratic in lambda. Now the linear part, lambda is equal to 6. And just use the discriminant to figure out the nature of the lambda. So b square minus 4ac equal to 9 minus 12 equal to minus 3, which implies lambda is not in real numbers. Only if it was in real numbers, then we would have had to solve for lambda. So therefore, the only real value of lambda for which non-trivial solutions exist is 6. So that was a couple of problems being solved. That's it for now.